Life in the wild is not guaranteed. Every step and every breath carries risk. There is no margin for delay. Awareness and reaction decide survival. In nature, individuals that fail to adapt are removed while those that adapt endure. Each day is a contest for essential resources: food, water, shelter, and safety. Threats emerge from predators, extreme climate, and environmental instability. There is no protection, only natural laws that every species must obey. Intensity and scale coexist. Only the strong, the precise, and the persistent survive. Survival is a continuous process, harsh, yet perfectly ordered. In the southern swamps of the Serengeti, lions survive through social structure and coordination. Competition for prey intensifies as hyena populations increase and herbivores scatter during drought. Every hunt is a test of energy efficiency. Lionesses lead the ambush. They move downwind, cut through herds of antelope, and target the weakest individual. A delay of a few seconds can mean failure. Young lions learn through mistakes, missed leaps, misplaced bites, and stolen kills. Individuals that fail to develop essential hunting skills are eliminated by natural selection. When food becomes scarce, the social balance shifts. Young males challenge territorial authority, and female alliances split off in search of new opportunities. This adaptive structure keeps the population in biological equilibrium. At night, a roar is not merely a display of power but a territorial signal. It defines the thin boundary between survival and extinction for one of the plains' top predators. Serengeti covers more than 30,000 square kilometers, encompassing grassland, woodlands, swamps, and scattered acacia shrubs. Each environment supports a distinct part of this vast web of biodiversity. More than 70 mammal species and over 500 bird species have been recorded here, along with thousands of insects and small reptiles. This diversity forms a tightly connected ecological network. Plants feed wildebeest, zebras, and African buffalo. Herbivores become the primary energy source for lions, cheetahs, and hyenas. Vultures, hyenas, and scavenging birds remove carcasses and restore ecological balance. Even insects play a vital role by decomposing organic matter and enriching the soil. One of the Serengeti defining events is its seasonal migration. Millions of wildebeest, zebras, and gazelles move across hundreds of kilometers in search of new grazing lands. This phenomenon shapes the rhythm of life on the plains and ignites intense hunting sequences led by lions, cheetahs, and hyenas. The African elephant shapes the physical landscape of its habitat. An adult weighs over 5 metric tons and consumes more than 130 kilograms of vegetation per day. Actions such as breaking branches, pushing down trees, or digging wells are not destructive. They are regenerative. When elephants open the forest canopy, sunlight reaches the soil, activating seeds and stimulating new grass growth. During the dry season, they dig for underground water with their tusks, creating vital sources for dozens of other species. Seeds passing through their digestive system are dispersed over long distances, expanding plant distribution. Elephant herds travel along fixed migration routes recorded in collective memory, linking waterholes and mineral-rich grounds. When elephant numbers decline, forests close their canopy, savannas lose their open structure, and biodiversity decreases. When elephants return, the ecosystem recovers through natural processes. Each herd functions as an independent ecological unit, consuming, regenerating, and maintaining the critical link between forest, grass, and water, the three pillars that sustain the Serengeti long-term stability. The African buffalo maintains ecological influence not through speed or aggression, but through population density. A single herd can include thousands of individuals moving as a unified mass across grassland spanning several square kilometers. As they travel, they graze mature vegetation, allowing new shoots to emerge. This controlled consumption keeps the grassland structure in a productive state. An adult buffalo can consume up to 15 kilograms of grass per day. The combined feeding of an entire herd can reshape a landscape within days. When confronted by lions, buffaloes do not panic. The largest individuals form a barrier while calves and weaker members stay in the center. If pressure increases, the herd launches a counterattack. A single horn strike can kill a predator instantly. However, this collective strength only holds when herd order remains intact. During extended droughts, as water sources dry up, herds fragment into smaller groups. These smaller units lose coordinated defense and become vulnerable to predation. Each fragmentation marks a temporary decline in the population cycle. When the rains return, grass regenerates and separated groups reunite. This process creates a natural rhythm of consumption, recovery, and reconnection. In the Serengeti, the spotted hyena serves as both predator and scavenger. Its social organization follows a matriarchal hierarchy in which dominant females lead and transfer status through lineage. A large clan may include up to 80 individuals, divided into functional groups for scouting, hunting, and defense. During chases, hyenas coordinate through vocal signals and wind direction. Their bite force exceeds 1,000 psi, strong enough to crush large bones and consume entire carcasses. Nothing of the prey is wasted. The dry season is when hyenas reach peak ecological performance. While other predators lose hunting efficiency, hyenas sustain food availability by scavenging and stealing kills. This flexibility stabilizes their population throughout the year. At night, when temperatures fall, hyenas become most active. They travel continuously within a 40-kilometer radius to locate carrion by scent. A powerful digestive system and specialized enzymes enable them to process decayed tissue and old bone, limiting disease spread across the plains. Each hyena clan functions as a biological recycling system. It converts dead animal matter into energy, maintaining equilibrium between life and decomposition in the Serengeti. The East African lion stands at the apex of the food chain, yet its dominance is never permanent. An adult male can weigh up to 225 kilograms and carries a dense mane that protects the neck during combat. However, territorial control is temporary and constantly challenged. As young males mature, they leave their natal pride to seek new territories. Conflicts between rival coalitions often end with severe injuries or death. When new males take control, the pride structure changes immediately. Cubs of the defeated males are killed, ensuring that only the genes of the victors continue. Females enter a new reproductive cycle, producing offspring that inherit the new bloodline. This ruthless cycle maintains genetic health and prevents inbreeding. During the dry season, when prey is scarce, lionesses hunt cooperatively. They coordinate in semicircular formations to isolate buffalo or zebra from the herd. Each ambush lasts only seconds but demands absolute synchronization. When the rains return, prides disperse, hunting alone or following migratory herds. Despite their power, lions depend entirely on prey abundance and environmental stability. Even a small shift in antelope density or rainfall timing can disrupt their survival rhythm. The cheetah achieves the highest locomotion efficiency among all terrestrial predators. Every muscle and joint in its body is adapted for extreme acceleration. It can reach 100 kilometers per hour in just 3 seconds, but it can sustain this speed for less than 30 seconds before its cardiovascular system overloads. For this reason, each hunt depends entirely on preparation. The cheetah selects a weak or isolated target, then approaches within 40 meters before launching the chase. Each sprint consumes roughly 20% of its stored energy. Failure in 2 consecutive hunts can lead to exhaustion and death. Even when successful, the cheetah must feed quickly within minutes before lions or hyenas arrive. Its slender body, deep chest, and long tail provide balance and control when changing direction at high speed. When not hunting, cheetahs rest on open mounds to monitor low grass areas and avoid encounters with larger carnivores. They perform only 1 or 2 hunts per day, spending the rest of the time recovering thermal balance and energy. Within the Serengeti system, the cheetah represents the biological extreme, where speed reaches its limit, and the limit becomes a mechanism of survival. When a hunt ends, the vultures take over. They detect carcasses from several miles away using exceptionally sharp vision. Different species arrive in a fixed sequence. The white-headed vulture arrives first, using its sharp beak to open the outer hide. The white-backed vulture follows, using its long neck to tear flesh from within. Last comes Ruppel's vulture, capable of flying up to 11,000 meters, completing the final stage of tissue breakdown. This feeding order ensures that an entire carcass is processed within hours, preventing bacteria and disease from spreading. Each individual can consume up to 20% of its body weight in a single meal, converting the remaining energy in the carcass into reusable biomass. When vulture populations decline due to poisoning or habitat loss, carcasses accumulate. Flies and bacteria multiply. Disrupting the ecosystem's natural balance. The presence of vultures therefore serves not only as a cleanup mechanism, but also as the ecosystem's first line of biological defense. Across the Serengeti sky, their circling flight patterns signal stability. The closing loop of nature's energy cycle, where death is transformed back into life. Amid the open Serengeti plains, ancient granite outcrops, known as kopjes, rise as remnants of geological history millions of years old. Each rock formation contains cracks, crevices, and shaded surfaces that provide critical shelter for many species, especially the leopard. In an environment with little natural cover, the structure of the kopje allows leopards to rest, observe, and plan ambushes. From elevated ledges, they track antelope movement, read wind direction, and choose an approach route. At the right moment, the leopard moves silently through fissures, using the terrain as a shield. A single leap releases all stored energy. The strike is over within seconds, often before the prey can react. After a successful kill, the leopard drags its prey up a tree to prevent scavengers from stealing it. This behavior is crucial for conserving energy in an ecosystem filled with competing carnivores. Kopje therefore functions as both habitat and hunting tool. A natural fortress connecting ancient geology with modern predatory adaptation. In the same landscape, a hidden leopard among rocks and a Maasai giraffe feeding on acacia leaves form a living portrait of Serengeti life, a balanced coexistence where each species displays its own survival design. The Maasai giraffe is a clear example of adaptive evolution. With an average height of 5 to 6 meters, it can reach the upper canopy of acacia trees. A nutrient-rich food source few other species can access. Its neck contains 7 elongated vertebrae, and a specialized valve system in the blood vessels regulates pressure, preventing blood from rushing to the brain when lowering the head. Each giraffe consumes tens of kilograms of leaves daily while dispersing acacia seeds through its droppings, helping the trees expand their range. In open habitats, height also becomes a defense system. When one giraffe spots danger, a single movement of the head or body alerts the entire group. During the rainy season, mating pairs separate from the herd. After a 15-month gestation, calves can stand within minutes, a vital adaptation in predator-rich grasslands. mature giraffe's kick is powerful enough to kill a medium-sized predator, which contributes to its high survival rate. The Maasai giraffe plays a structural role within the Serengeti ecosystem, regulating the mid to upper vegetation layer and maintaining the vertical balance of photosynthesis between woodland and open savanna. At the edges of the Serengeti, the landscape transitions into the Miambo woodland, where deciduous trees dominate and the food chain shifts from predation to decomposition. Above the canopy, the marabou stork, with a wingspan exceeding 5 meters, circles humid areas, detecting carcasses from several kilometers away. They arrive after vultures and feed on remaining tissues, reducing dry bones to nutrients that return to insects and soil. On the ground, black-backed jackals work through the night, hunting rodents and insects while clearing smaller remains. As they dig, soil microbes and fungi become active, initiating microscopic decomposition. Within the forest layer, Miambo trees absorb vast amounts of carbon. Retain moisture, and regenerate through the organic matter produced by these very processes. When elephants move through, they open pathways in the vegetation, allowing sunlight to reach the forest floor and trigger germination. The combined action of birds, mammals, and plants forms a self-cleaning ecological mechanism, where dead energy is continuously transformed into new life. The Miambo fringe represents the final tier of the energy cycle, where matter does not disappear but returns to the earth to begin the next round of renewal. The entire Serengeti functions as an ancient regulatory system in which every process sustains the balance of energy. Rain revives the grass. Grass feeds herbivores. Herbivores sustain predators, and their deaths return nutrients to the soil. Elephants clear paths for water. Buffalo trim grasslands. Hyenas and vultures remove carcasses. Crocodiles link the flow of energy between river and plain. When any link disappears, the ecosystem compensates by adjusting population density, behavior, and range. This mechanism allows the Serengeti to remain stable for thousands of years without external intervention. Protecting the Serengeti is therefore not only about preserving individual animals, but about maintaining the interconnected system itself, a self-regulating model of nature where life and death coexist to sustain the order of existence. The forest savanna mosaic of Guinea forms a transition zone between humid rainforest and dry grassland. This mixed terrain of shrubs, shaded patches, and open areas supports both predator and prey. Leopards here have developed hunting behaviors distinct from those of open savannas. They rely on dense cover, moving in complete silence. Striking only when within 10 meters of the target. Their golden brown coats marked with dark rosettes provide perfect camouflage under filtered light. After a successful kill, the leopard drags its prey into a tree to protect it from hyenas and lions. This behavior extends feeding time and reduces the need for continuous hunting, conserving energy. Their exceptional climbing ability, flexible muscles, and rapid reflexes make them perfectly adapted to this environment, where long chases offer little advantage. Each individual controls a territory of about 20 square kilometers. When trees are cut and vegetation thins, hiding opportunities decline and survival rates drop sharply. Thus, this forest grassland mosaic serves as the biological foundation for sustaining West African leopard populations. In the heart of the Somali thornbush, the Grevy zebra represents the physiological limits of mammalian endurance. Its elongated kidneys allow near-total water reabsorption, enabling survival for several days without drinking. When temperatures exceed 40 degrees C, sweat evaporates faster from the black stripes than from the white ones, creating micro-pressure differences that assist natural cooling. Large ears amplify sound and release heat through dense networks of blood vessels. Each step of a migrating herd is a calculated use of energy, approaching water sources at dawn and retreating as sunlight intensifies. When rare rains arrive, they exploit temporary puddles, using their lips to filter mud for drinkable water. The survival of the Grevy zebra depends not on speed or strength, but on metabolic control. In a land where water is more valuable than food, this species stands as proof that evolution can reshape physiology to match extreme aridity. In the heart of the Somali thornbush, the Grevy zebra represents the physiological limits of mammalian endurance. Its elongated kidneys allow near-total water reabsorption, enabling survival for several days without drinking. When temperatures exceed 40 degrees C, sweat evaporates faster from the black stripes than from the white ones, creating micro-pressure differences that assist natural cooling. Large ears amplify sound and release heat through dense networks of blood vessels. Each step of a migrating herd is a calculated use of energy, approaching water sources at dawn and retreating as sunlight intensifies. When rare rains arrive, they exploit temporary puddles, using their lips to filter mud for drinkable water. The survival of the Grevy zebra depends not on speed or strength, but on metabolic control. In a land where water is more valuable than food, this species stands as proof that evolution can reshape physiology to match extreme aridity. When rain transforms lowland plains into shallow lakes, the hippopotamus becomes the core of these temporary aquatic systems. They spend most of the day submerged to regulate temperature, while their skin secretes a red, oily fluid that acts as both sunscreen and antibacterial protection, a natural biological coating. At night, herds leave the water and travel along fixed routes, each adult consuming about 30 kilograms of grass. Their paths compress the soil and carve channels that guide water flow, creating small streams feeding the vegetation around ponds. Hippo dung, rich in nutrients, provides carbon and nitrogen for algae, bacteria, fish, and waterfowl. As water levels drop, the remains of algae and sediment form fertile layers that support the next rainy season. A single hippo population can maintain the fertility of a floodplain for years. If they disappear, ponds dry faster, channels close, and nutrient cycles collapse. In the savanna, the hippopotamus is not merely a heavy grazer. It is a hydrological engine that sustains the continuous circulation between water, soil, and life. Along the Mara and Grumeti rivers, the Nile crocodile dominates the aquatic ecosystem. An adult can exceed 5 meters in length, protected by thick armored skin capable of withstanding immense pressure, and can live for over a century. When migration begins, crocodiles position themselves at strategic river bends where the current forces prey toward narrow crossing points. For hours, they remain motionless, conserving energy through slow blood circulation that regulates body temperature. Every movement of antelope along the riverbank is mirrored in the surface ripples above them. When a target steps into the water, a sudden tail sweep breaks the surface, and the first strike decides the outcome. Crocodiles do not hunt for immediate need but store energy for weeks. Excess meat is anchored underwater, where low oxygen levels slow decay. The scent attracts fish, turtles, and scavengers, completing the river's food chain. Through a passive yet efficient hunting system, the Nile crocodile serves as a link between land and water. Returning the energy of the plains to the river through a precise, patient, and necessary process of predation. The East African oryx represents the most advanced control of heat and water among all grazing mammals. When air temperatures exceed 46 degrees C, blood vessels surrounding the skull function as a countercurrent cooling system. Blood is cooled before reaching the brain, maintaining stable neural function. During weeks without rain, the oryx extracts water from roots and leaves, using every trace of moisture stored within plant tissue. Its body produces little sweat, and metabolic activity slows at midday, shifting all movement to early morning and late evening. Within the savanna system, the oryx maintains equilibrium. It does not migrate, does not overgraze, and regulates moderate grazing density. Every organ, from blood vessels to kidneys, reflects millions of years of adaptation to arid heat, an evolutionary design that sustains physiological stability under extreme desert conditions. Within the Serengeti ecosystem, rhinos act as primary regulators of vegetation. Each adult can weigh up to 2 tons, yet their movements sculpt the microtopography of the plains. By grazing close to the ground, they create biological gaps where sunlight reaches dormant seeds. Their 2 horns, made of keratin rather than bone, serve as both defensive tools and instruments for clearing shrubs. Rhino dung is rich in nitrogen and microorganisms, transforming resting areas into natural fertilizer zones. Insects and small birds follow these dung sites to feed and breed, forming secondary ecological communities. When poaching reduces rhino populations, grass grows too dense, dead biomass accumulates, moisture declines, and smaller grazers lose food access. Conversely, when rhinos are protected, their slow grazing restores equilibrium naturally. In the food chain, they compete with no one directly, yet they control grass density and soil structure, fulfilling an ecological role equivalent to an architect shaping the African landscape. Across the East African grasslands, rain acts as the signal that triggers the entire biological cycle. When the first drops fall, the cracked soil splits open, and young grass emerges within days. Herds of antelope and zebra spread across the plains, marking the peak of available energy. During this brief window, the cheetah reaches its highest hunting activity. Every opportunity must be taken before the grass grows tall and prey disperses. The cheetah selects open ground, aligning with wind and light direction to minimize detection. When prey moves within 40 meters, the body tenses like a compressed spring. Acceleration surpasses 90 kilometers per hour in 3 seconds, releasing all stored energy over a distance of less than 500 meters. If successful, it drags the kill to an open area and feeds rapidly before hyenas or vultures arrive. When the dry season returns, the grass withers. Herds migrate and speed loses its value. The cheetah reduces activity, hides among thorn bushes, and survives on smaller prey. For this species, life is a constant threshold between strength and time. Every chase is a decision between nourishment and exhaustion. At the heart of Africa lies the Congo rainforest, spanning more than 7 million square kilometers, the second largest tropical forest on Earth. Its multi-layered canopy filters most sunlight, creating a consistently humid and stable environment year-round. This immense energy system is sustained by the Congo River, stretching nearly 700 kilometers across 6 nations. Continuously transporting sediment and nutrients. Within this ecosystem, over 10,000 plant species and 400 mammal species coexist through an interconnected cycle of recycling and renewal. Chimpanzees and bonobos share the same region, but exhibit distinct behaviors shaped by the natural boundary of the river. Beneath the canopy, a layer of decomposing leaves several meters thick provides nutrients for seedlings, microorganisms, and symbiotic fungi. Rainfall occurs almost continuously, allowing giant trees to grow beyond 50 meters in height. Each tree crown functions as a miniature ecosystem, supporting insects, birds, and small mammals in a web of dependency. When roads are built or logging begins, the hydrothermal cycle breaks down, humidity drops, rainfall patterns shift, and the topsoil erodes. The Congo rainforest is not only a carbon reservoir, but also a climate regulator for the entire continent. Its loss would disrupt the moisture balance across the tropical zone of Africa. Adzala National Park in the Republic of the Congo is one of the few remaining rainforests dense enough for leopards to exist undetected. The thick canopy limits visibility, forcing this predator to rely entirely on sound and subtle movement. Leopards here have compact, muscular bodies and move silently over layers of decaying leaves. They hunt at dusk, when the light fades, using the brief transition between brightness and darkness. Instead of pursuing prey, they advance slowly, waiting for it to pass within a few meters. Each strike must be perfectly precise, since the dense forest allows no room for extended chases. After a successful hunt, the leopard drags its prey into the trees to avoid detection by larger animals such as black leopards or baboons. Females give birth to 1 to 3 cubs after a 100-day gestation period, hiding them in hollow trees and teaching climbing and concealment for several months before independence. In Adzala, each adult controls a hunting territory larger than 20 square kilometers. When tree density declines, territories shrink, conflicts increase, and populations weaken rapidly. For this species, the rainforest is not only shelter, but the biological condition that determines its survival. Bwindi Forest in southwestern Uganda provides the only habitat where mountain gorillas still live in sufficient density to maintain stable social structures. Each group typically includes 10 to 20 individuals, led by a dominant silverback male weighing more than 180 kilograms. Behavior within the group is regulated through hierarchy and physical gestures. Communication occurs through short vocalizations, chest beats, and posture signals. Their diet consists of leaves, shoots, stems, and occasional forest fruits. By consuming large amounts of vegetation, gorillas disperse seeds and clear space in the understory, allowing sunlight to reach the forest floor and promote regeneration. Each group maintains its own range, but boundaries remain flexible to reduce conflict. When offspring mature, they leave to form new groups, ensuring genetic flow across the population. Tourism is strictly controlled, allowing only a few habituated groups to be visited daily to reduce disease transmission. Through the tourism conservation community model, Biwindi sustains both local livelihoods and the survival of this critically endangered primate. The mountain gorilla is the ultimate indicator of forest health. Where they survive, the cycle of regeneration remains active. Mount Kilimanjaro, rising over 800 meters, is the largest isolated mountain on Earth. From its ice-covered summit to the base, 4 distinct ecological zones change with altitude. Permanent ice at the peak provides a constant water source, melting into hundreds of streams that flow into the lower rainforest. The forest surrounding the mountain covers more than 1,600 square kilometers, hosting thousands of endemic plant and animal species. The upper canopy layer traps moisture, reduces evaporation, and maintains humidity essential for the regional climate. Among the most distinctive species here is the black and white colobus monkey. Its light body, long tail, and hands without opposable thumbs allow rapid movement through the treetops. It lives entirely in the trees, feeding on young leaves and ripe fruits, and rarely descends to the ground. Its social structure includes cooperative infant care, which increases the survival rate of the young. The Kilimanjaro rainforest functions not only as a biological habitat, but also as a natural water reservoir for millions of people living downstream. However, accelerated ice loss and deforestation are shortening the water cycle and threatening regional climate stability. This ecosystem illustrates the direct connection between topography, climate, and biological structure, from the snow at the summit to the canopy below, from the mountain peak to the open plains. The journey reaches its end, spanning landscapes that represent the essence of an entire continent. From the Congo rainforest with its immense river, to the cold Ethiopian highlands that shelter rare species, and finally to the deep green forests beneath Mount Kilimanjaro. Each environment is more than scenery, it is a foundation of survival. It regulates climate, protects water sources, and sustains the planet's natural balance. Within these forests, countless species remain connected through invisible ecological networks. Trees rise toward the sky, animals move along corridors of life, and humanity finds both sustenance and inspiration. Recording these images and telling these stories preserves a reminder that their value still endures. The untamed wilderness continues to exist, even as it faces the pressures of climate change and exploitation. Africa, with its ancient forests, still holds secrets yet to be revealed. Each landscape stands as a call for protection, so that today, and for generations to come, nature will continue to echo the living symphony of the wild.